Good morning, I'm Robin and I'm going to be playing around with some shapes for you this morning. I'd like you to see if you've got a pencil, a ruler, paper, protractor to draw a 90-degree angle or a set square, and you can also use a pair of scissors to cut out shapes. That's all we're going to be needing to do, and you can have a pocket calculator handy as well. Right, now on your piece of paper, I'd like you to draw a square. It doesn't matter how big it is, as long as each square has got the same length sides and you've got your 90 degrees. Once you've done that, you can label the sides H, and then you can draw the diagonal, which cuts the square in half, and you're now going to have two equal triangles, and each one will be a right-angled triangle. See over here, here's a right angle, there's a right angle, that side is H and that side is H. Then, a simple thing, I'd like you to draw a rectangle. Any side length A, any side length B, you label the sides and you draw in the right angles. Once you've done that, once again you can draw the diagonal in, and now you can see we've got two other right angled triangles. This one has a side B and a side A. What we would say in a triangle, that is the base and that is the height. Right, so there's nothing new so far. We know that a square has 4 right angles, and the area of a square is the side multiplied by the side. A rectangle is 4 right angles, and it's the length of the one side multiplied by the other. The right angle triangle has one 90-degree angle, which is your right angle, and the area is half the base times the height. And the base and the height are at 90 degrees to each other. Right, nothing new. Now, on any triangle, the longest side is always opposite the largest angle. So you can take any triangle that you can draw, you can find anywhere, use your protractor and measure it, and you'll find that the longest side has to be opposite the largest angle. This probably isn't new either. Now we're going to add a new word called the hypotenuse. The longest side of a right angle triangle is opposite the 90 degrees, opposite the right angle, and it is called the hypotenuse. So now we're going to start a program of drawing. I'd like you to start drawing a square on your page about halfway down. Doesn't matter how big your square is. And then from the bottom right hand corner of that square, you draw another square coming down like that. Okay, once you've drawn those two squares, I'd like you to draw the hypotenuse. So you can see that there are two sides, line A here and line B at 90 degrees to each other, and you join the two to form the right angled triangle, and that is your hypotenuse. So now we've got a triangle and we've got 3 lengths. One length is a big A, which is your height, and that is opposite an angle here which I've labeled A. The other is the base, which I've called B, and that's opposite a little angle B. And then you've got the 90 degrees, or your right angle, and opposite that is the hypotenuse. Now I'd like you to draw a square on the hypotenuse. Okay? And I'm going to call this a classic diagram. This is a diagram we're going to be using lots of times when we do examples like this. So there's a first square, there's a second square, there is a hypotenuse, and I'd like you to draw the square on the hypotenuse. So you can measure a 90 degree with a protractor, or you can use a set square, and those sides all have to be equal, and of course you've got 4 90-degree angles. Now we can rotate this. So if we rotate it one way or the other, we've still got, there's the right angle, there's the hypotenuse, there is a square on the hypotenuse, and same here. Here's our right angle, there's our hypotenuse, and there is a square in the hypotenuse. Right, now we take that classic diagram and I'd like you to take the line from A and you extend it upwards by the length of side B. So that goes up, and that's going to form a side now that is going to be as long as B plus A. Then over here, I'd like you to extend that line on the square B by the length A. So that means this side will be B plus A. So now we've got two sides here. That is B plus A, that is B plus A. They're at 90 degrees to each other. Then we complete the square around that. So now we've got a side all the way along here. And you can see that the top side, if that is B and that is H, that'll be length A and that'll be length B. So you can see these have interchanged, those have interchanged, but the overall length of both of these sides is A plus B. Right, so the area of that of the square on the hypotenuse will be the area of the big square minus the area of the four triangles. Okay, so look at your diagram there, and we can see here is the big square, that is A, B, B, A, this big square here, and there are four triangles. So if we take away those four triangles, we're left with the area of the square on the hypotenuse. So we say the area of the square is the same as the area of the big square all the way around minus the four triangles. This is a time where if you want to come back to it later, you can cut it out with scissors and you can take away those four triangles. Right, now I'm going to get you to draw a new square. So we're going to have a new big square, and it's going to have the same side lengths, and the side length will be A plus B. So in this case, I'd like you to draw the A on the top and the B on the top, and then the A on the left and the B on the left, in that order. So now you can see we've got a square which is of side length A in the top left, and another square side length B in the bottom right. Okay, it's the same square size, length is A plus B, but we've got the squares in different places. You can see what we're left with are two rectangles. Okay, so the area of that square will be A squared, and the area of this square will be B squared. Okay, here are the two triangles that two rectangles that we left over with. Now we're going to draw the diagonals across those rectangles. And you can see as we draw those triangles, we've got four triangles now. That side length is A, there's a right angle, that side length is B. That side length is A, that side length is B, there's a right angle. Okay, so now we can see we've got four right angle triangles. Now if we look for the area of these right angle triangles, the area of one of them is a half the base times the height, so that is a half A times B, and the area of all four is 2 times A plus B, because we've got four halves. 4 halves is 2, so the area will be 2A times B. Okay. Now we're going to be looking at these two squares. Now, if you look at the same way I do, on the left-hand side, we've got a square which is A squared and a square which is B squared. And then we've got 1, 2, 3, 4 triangles. On the right-hand side, we've got a square which is A plus B all squared. We've got 4 triangles, 1, 2, 3, 4. Which means that if we take off the 4 triangles from the square on the left, we're going to be left with A squared triangle and A squared square and a B squared square. And if we take away the 4 triangles on the right, we're going to be left with the one square, which is h squared. So what that means when we compare these two, in any right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Right, I'm going to call this a classic diagram, and we rotate it at any angle we want. Okay, so let's look at that. That means whatever triangle we've got here, we've got the right-angled triangle. The square on that hypotenuse will be the same as the sum of those two squares. So we take those two areas, they have to match that. Right, this is an example that I was sent to look at, and it says complete this exercise. ABCD is a rectangle. You can see it in the top right hand side. The line length AB is 56 millimeters and AD is 33 millimeters. Calculate the length of the diagonal from B to D. So I draw my classic diagram. On the top I've drawn in the side length 56 from A to B, and I've drawn in the side length 33 from A to D. And then I've drawn the hypotenuse, which is the same as the diagonal. And now we do a little bit of maths. So the area of A is 33 times 33, which is 1089. The area of the square AB is 56 times 56, which is 3136. Both of those you can use your calculator. The total area of the squares on the other two sides is 4225, which means that the square on the hypotenuse must have an area of 4225. So to find the length of that, we have to square root that. And you can use your calculator and find that the length of that is 65. The next one, we're looking at the triangle on the left-hand side, where we've got the hypotenuse with a length of 13, the vertical with a length of 5, and an unknown horizontal. Now I've drawn it at a slightly different angle just to show that it doesn't really make a difference as long as you have your 90-degree opposite your hypotenuse. So we look at that, and the square on the hypotenuse's area is 13 times 13, which is 169. The square on the side length 5 is 5 times 5, which is 25, which means that the square on the base must be the difference between the two. We take 169 minus 25, and the square on the base is 144. So to find the length of the base, we take the square root of 144, which is 12. Right, we're going to look at the other side now of that same diagram. And we say we've got a right angle, we've got 21 as the hypotenuse, it's opposite the right angle 1. And the height of that triangle is 5. So we take the square on the hypotenuse, which is 21 times 21, which must be the sum of the squares on the other two sides. The one side is 5 times 5, which is 21. So the remainder is 441 minus 25, which is 416. And we use our calculator to find the square root, because it's not a perfect square, and that is 20.35. Right, this just tells you that we haven't once mentioned any long Greek words. We've used the word hypotenuse, which is just saying in a right angle triangle that's the longest side. And every other calculation has been either multiplying two numbers together or a little bit of addition or subtraction.